2, 1, and we're live.
Thank you, everyone. Tonight we are having our Faces of Physics speaker series, and we have our guest speaker, Dr. Tina Cartwright. I want to thank a few people before we get started. So specifically, I want to thank Eli Williamson. He is our new president of SPS. And I want to thank AJ Messenger. He's our new vice president for SPS. They have done a fantastic job this semester of organizing speakers, and it is really those two students that are spearheading this effort, and they have done a phenomenal job with it. So congratulations to those two. I also want to thank the physics department, the College of Science and Marshall University for basically sponsoring some of the things that we do, and also just helping out the SPS group where they can and supporting all of our endeavors that we do. That is greatly appreciated. I'd like to thank the American Institute of Physics. They've also helped sponsor this speaker series, as well as the West Virginia Space Grant Consortium. They are currently sponsoring this speaker series. So in our physics department, we have about half a dozen faculty members. 4 of those are active in research. If you're interested in checking out our webpage, that's www.marshall.edu/physics. We have a couple areas of emphasis. We have a pure physics track, we have an applied physics track, a biophysics track, a medical physics track, as well as a medical imaging track. So these different areas of emphasis will allow you to get a BS degree in physics, but will allow you in some cases to pick up a minor in these other fields. So if you have an interest in biology and physics, you can get the BS degree in physics and easily pick up the minor in biology, all within the 120 credit hours. So if you have any questions about that, feel free to reach out to me. My email is mcbride@marshall.edu, or you could contact the physics department. I am sure somebody will put you in touch with somebody that knows the answers to your questions if we don't particularly. So Marshall's got about 9,000 undergrad students, about 2,500 graduate students. It is recently an R2 designated research university. So feel free to check us out if you're interested in any of the stuff that you talk or hear about Tina talk tonight, Dr. Cartwright. Please feel free to email her. I'm sure she'll be happy to address any questions you have about the College of Education here on Marshall University's campus as well. So I think with that, I'll turn that over to you, Eli.
All right. Thank you, Dr. McBride, and thank you to everybody out there joining us tonight. This will be the 14th talk in our Faces of Physics series, and I'm very excited to hear our speaker tell us about her career in meteorology as well as science education. I'll be introducing her shortly, but first we have a few quick announcements. So after the presentation, just like all the other talks, we will have a Q&A session at the end. We welcome and encourage you to share your questions in the YouTube live chat. If you enjoyed this presentation, we hope that you'll join us for future talks in the series. More information about future talks will be announced soon. If you'd like to receive email updates about upcoming events, we have included information in the YouTube description where you can ask to sign up. While you are down towards the description, we would also like to ask you to subscribe to our YouTube channel and click the little bell icon to be notified of our future talks and other videos here on the channel. If you wish to watch some of our previous talks, they can all be found here on our YouTube channel. Now it is my pleasure to introduce our speaker, Dr. Tina Cartwright. Dr. Cartwright is a professor of education at Marshall University and former West Virginia state climatologist. Her lifelong interest in science began with a 7th grade project aimed at determining if cloud conditions can predict weather patterns, which included visits to the local location National Weather Service. After teaching meteorology and working with the West Virginia science teachers, she began to see that many students are underprepared for science, technology, engineering, and math studies. The goal to reverse that trend brought her to Marshall University, first as the program director for the MU Advance program, a National Science Foundation funded initiative that seeks to advance women in academic science and engineering careers, and then as a College of Education and Professional Development Science Education faculty member. Dr. Cartwright is a West Virginia first-generation college student who graduated from West Virginia University and Florida State University. She received a Barry Goldwater Scholarship as an undergraduate and a NASA Fellowship to support her Ph.D. in meteorology from Florida State. She worked as a research meteorologist for Lincoln Laboratory and served as the West Virginia state climatologist before beginning her career at Marshall University as a science education professor. I first met Dr. Cartwright as her advisee for the College of Education and Professional Development. From there, she was also over the PERT research program that I participated in as a pre-service teacher. During this program, I was able to get some very valuable research experience and work with a current teacher as well as a high school student to learn more about how research in a collegiate setting is done and the environment within. Thanks again to all of you for coming, and huge thanks to Dr. Cartwright for taking the time out of her busy work schedule. And without further ado, Dr. Tina Cartwright.
Oh, thanks, Eli and Dr. McBride. Let me share my screen. I appreciate all of you joining in. I probably have a few students on the line. And so for my students that I bribed to attend with extra credit, I want you to think of a question that you'd like to ask in the chat box at the end of the talk. And as you're thinking of the question, go ahead and enter it in the chat box with your name. In case your user ID, we can't identify who it is, we want you to make sure you get those extra credit points. So if you have a question that pops in your mind as I'm working through the talk, go ahead and enter that in the chat box with your name. All right. So thank you everyone for joining in. My name is Tina Cartwright. They've very well introduced themselves. I just wanted to talk a little bit about my trajectory of my career because it's definitely not necessarily a straight path, like many of you will find your own careers. And so it's a journey. And then I love to talk about Pluto because Pluto has had quite a journey as well. And then what lessons can we learn for our own lives from Pluto and how science works? So sort of an overview, I just want to talk about really the importance of interest in careers. I know that really drove my career in especially the early days and how my interest has changed over the years. And then of course I mentioned Pluto and how science works, which we kind of call that the nature of science. So it all began, as Eli mentioned, I was interested in the weather and so how I could use current clouds to predict future weather. And I put this graph up here. My students who are on the call might recognize it because it's about fronts. And so the cold front is depicted on the left side. And so with the cold front, this is often associated with really heavy rainfall and a drop in temperature. I think we've had a few of those cold fronts stick around a little too long here in West Virginia. Our spring sprang and then has come unsprung, but maybe it's spring again today. It might not be tomorrow. It's hard to know. So, and with those cold fronts, we see really like very puffy clouds. We call those cumulus clouds, cumulonimbus clouds. And so they're indicative of very unstable air that's rising quickly to give us those bumpy clouds. Versus the diagram that's on the right is a warm front. That's on your weather map, you'll see that as a red line with a little semicircles. They're associated with really gradually rising air, which is associated with more flat clouds, right? And so if I had known about these diagrams when I was in 7th grade, I think I would have had a little better results, let's just say, because I would be looking for the passage of fronts, because the fronts were really the key that I was kind of missing in 7th grade. But what it did provide me was a trip to the local National Weather Service. And this is what computers looked like back then, right? We're talking about, oh, I don't know, like in the 80s, early 80s, when all this transpired. And so I love technology. I've always enjoyed technology. I'd take apart my pen and try to put it back together. And I mean, I just have always enjoyed technology. And so when I saw these radars and the computer system that they were working with at the National Weather Service, I just like, wow, this is super cool. And so that sort of led to me becoming interested in meteorology and also saying, this is what I want to be. And so that interest that spurred in those really important middle school years, that's where the research shows, is that we sort of establish those interests in those really important middle school years. And so that has been supported by research. And so the National Educational Longitudinal Study, which began in 1988, followed 12,000 eighth graders, right? And they were asked many things. They took assessments in reading and math, and, you know, they were surveyed a lot. And so their grades were collected, and that those surveys continued all the way through until 2000, when they were about 28, right? In the year 2000. So when these 12 eighth graders all the way through, all the way through their college, early stages of their career. So when they were in eighth grade, they were asked, one of the questions they were asked, what kind of work do you expect to be doing when you are 30, right? Of course, when you're eighth grade, you think 30 is very old, right? So what are you going to do when you're very old at 30? And so those students who expressed an interest in science, like they identified they were interested in a science career, right? What did they end up doing? And so the results showed by 2000, right, that those students who expressed an interest in a scientific career were 2 times more likely to have graduated with a degree in life science, and shockingly 3 times more likely to have a degree in the physical and the engineering sciences. And that was a way more significant, stronger predictor than achievement. It out predicted their math scores. It out predicted all the other aptitude scores that we think are the ones that hinder us from going into sciences. So the interest, that established interest, helps provide the motivation, right, to pursue the harder sciences that are often a prerequisite of these kinds of degrees. And so that it's really important that we reach out and service and really target these middle school students, because that's where their interest starts to be defined and become clear. So my own journey, I did have an interest in science, even and by eighth grade, even at that. And so I mentioned in the bio, I am a first generation college student. So where are we going to go to school? We're going to go to WVU, right? And so my parents took me to Morgantown and dropped me off. And they often talk about that was the hardest day in their lives, right? Leaving me in Morgantown. I loved Morgantown. I loved the academic environment, the college football days, all of that. It was a great place to be. But I had trouble, like, you know, acclimating in maybe the social ways, because there was really, I went to a really small Christian school in Putnam County called Tays Valley Christian. And so I didn't know anyone on the campus at WVU, nobody. And so although I'm very outgoing, and I found a home in the honors college, and that was huge. I made friends that were also interested in, like, you know, I don't know, studying, you know, being a good student. That was also in their plans. I was in the marching band my freshman year, so that was quite an experience. And because I had never marched before, I had been in like sit down concert band. And so that was quite an interesting experience. But it was a big transition. That network, and when my own children went to college, I was like, you've got to find a way to acclimate to the community within the community of the school, you know, so that was a huge help. And then as I'm transitioning through, I didn't have a lot of scholarship money. And so as a first generation college student, it was challenging at times. And so I was within the honors college. And so all my other friends who are science majors, I knew I wanted to go into meteorology. And so I had a choice of geography or physics or math major. And my math skills were a little behind. I had to take pre-calculus before I could take calculus. And so I was already starting behind to be a physics major. And quite honestly, that was very intimidating to me, right? You know, because only the smart kids at my school took trig. Okay. You know, so it was a huge transition to beginning to think about, oh, I can do calculus and I can do all these like technical sciences. I'm like, okay, one step at a time, one homework set at a time, one test at a time. You just have to chunk it in small pieces and not get behind. Getting behind is the death toll. You got to stay on top of it and make sure and aim for, I've seen this in terms of success, aim for 100% mastery. Don't let anything slide by and think it's okay if I don't understand that. Go to the professor's office hours. I was a pain to my professors, right? I would go to the office hours, nothing intimidating. I'm going to ask you until you can explain it so I can understand. That's the demanding thing that I just had. And so all of my friends who had, I ended up declaring as a geography major with a physics minor, and then I took all the calculus through partial differential equations. The advisor that I had in the geography department, his name was Ken Martis, and he was awesome. He was so supportive, and he's like, let's Tina, let's find out what other meteorology programs are doing, and we'll have you do as many of those classes that we can. And so I always, it's kind of funny now to think about it. We didn't have an internet. I started college in 1990, so there was no internet. That was came about while I was in school. And so we wrote letters. I went to the library and got this big fat book that had all the academic programs of all the universities in the country. And so I looked up those that had meteorology. And so we sent letters and said, would you send us your list of curriculum? And so they had 3 departments mailed back their curriculum. And so we followed it as best we could. And so since I wasn't in the College of Science, it was College of Arts and Sciences at WVU, but I wasn't technically a science major according to the Honors College, I wasn't notified about, you should consider applying for the Barry Goldwater Scholarship. Well, because I'm friends with the science majors, they told me about it. I'm like, well, that sounds very interesting. I think I'd like to apply. I'd like to do some weather related research. And so I did. I knocked on the door and explained and made my case for applying. And they were like, go ahead, put together a packet. And so I had done a summer internship, huge, right? Volunteer basis. I wasn't paid. I went to my local National Weather Service and said, I'd like to learn. And so because of that summer and the connection that I had with them, they're like, okay, Tina, we'll help you with a research project. And then geography department new hire was all into like GIS and mapping, which was brand new at that time as well. And so we were like, let's look at the study of forest fires and how they impact flooding. And so all that came because of the connections and me knocking on doors. And ultimately, surprisingly, shockingly, I received that scholarship to do research as an undergrad. And I think that changed the course of my life. And that's why I'm also a big supporter of doing research for undergraduates in the sciences, because although I was interested in meteorology, I didn't know what research was or how it worked or how it could be my career. I didn't have to go and work at the National Weather Service someday. I could actually work in academia and do research to better understand how weather works. And so really that turned the corner for me for thinking about, research, I could get my PhD. This is something that sounds interesting to me. And so I have this little random mail flyer pop up because in the physics building, there was a poster on the wall that said, are you interested in pursuing your PhD in the STEM fields? And are you an underrepresented female or minority? Take this little mail flyer and get more information. So I did. I pulled it off the wall and I slapped my address and my name, interest in, and they sent me back packets. I applied for it. I ended up getting it and was awarded a 6-year NASA fellowship over $100,000 with summer pay and paid me for 6 years of school. So don't just walk by those flyers in the hall. It's amazing, the opportunities. And now they're in your email inbox. People are sending you information now. You're overloaded with information now. But I had to go through and, peel it off the wall. But that, again, added to my experience, provided me, I didn't have to worry about finances. I got to, again, spend summers at NASA learning how research is done in that context, which is so unique and so fascinating and so interesting. So from WVU, I applied to graduate school in meteorology and went to Florida State, which is located in Tallahassee. And so I got to spend my 2 summers of the first 2 years while I was in undergrad doing research at Goddard. So Goddard is the NASA facility that's outside of DC. It's in between Baltimore and Washington, DC. And they focus on satellite-based research there. And of course, meteorology, we're interested in satellites looking back. You know, I'm going to talk about Pluto, where we send satellites to investigate the outer reaches of our solar system. At Goddard, they're looking back at Earth, right? Because those are where we're getting information about our climate system, our weather system, our land surface processes, the raising the Himalayas getting higher. We talk about plate tectonics. That's happening with data from NASA and from satellites. And so I was able to see part of that. I like this collaboration icon, that picture that comes up, because that's what I saw work so well at NASA. They have teams who have expertise in lots of different areas of science. And because NASA wants to promote products that are cohesive and that are connected, there's so much collaboration and really goodwill between scientists that sometimes I didn't see in the academic field. So anyway, so that was very interesting, and I really sort of thrived in that that arena, and I love that collaboration, and that's what I've sought to do professionally as well. Is like work together and help raise each other up. And as I was finishing my PhD, it was a very roundabout journey. I have this little like life vest or life ring comes out because, you know, I was doing my PhD, finishing my PhD while I was living in West Virginia. It's been, you know, it was a long journey. It took me about 7 years to get it done. And I'll never forget leaving Tallahassee with a printout of a bunch of papers. I didn't have the access of the libraries of the volumes of research now that you can access on your laptop, you know, on your iPad. You know, you could be looking at research papers, you know, when you're standing in the line at the grocery store. I'm sure you do that, right? But I had to print out papers. And so there was one paper that really inspired and let me make some changes to my research to make my professor happy, so he could sign off and let me finish my doctorate. And so that's, you know, always keep plugging and always keep searching for answers, searching for ways to improve your work, and you never give up. I mean, that's ultimately what led to me being able to finish. And so from Florida State, I did, as Eli mentioned, I did do some weather-related research at Lincoln Laboratory. The interesting thing, I was working on a project team there that was supporting air traffic controllers to forecast the movement of thunderstorms particularly. And so the interesting thing now, like 25 years later, we all have that technology that was so cutting edge that only the air traffic controllers and the FAA had paid money to get this developed product. We all carry it now in our phones. You know, when you sort of look at the radar, you can say, what will it be? That's what my team was working on 25 years ago. We were trying to track where the current radar was showing the thunderstorms motion and projecting that. So air traffic controllers have better control of their airspace and have planes ready to re-enter into the airspace and land after the passage of those thunderstorms. So that was super cool. Then I moved and came back to West Virginia and worked at West Virginia State and taught meteorology there for about 6 years. And that's when I started to become more and more involved with the GLOBE program and working with teachers in professional development settings. And the GLOBE is an international environmental science program. I talk to my students about it. I also have a summer workshop coming up for any teachers online. Email me that. Email me and I'll give you some information about a workshop that I'm hosting for elementary GLOBE. And that's really an international environmental science, helping teachers work with students to collect data, make observations that then are shared around the world, right, through this wonderful internet, and then also shared with scientists so that they can supplement surface observations with data collected with classrooms and teachers. And then ultimately I started writing grants with the National Science Foundation to work and expand those outreach opportunities. And again, I saw that there was definitely a tendency of underpreparedness from our STEM students. I would have students come to me at a West Virginia State and say, I'm interested in being a meteorologist. I'm like, okay, so how are you with math? You know, you have to be willing to work hard, especially if you didn't have, like I didn't have calculus in high school. I had to make up that ground and invest extra time and effort to get there. And so it was troubled. And so that's when I started to become more and more transitioning into education, and ultimately working with elementary students and middle school students and high school students and their teachers to increase their awareness and ability to engage in like innovative instruction that's meaningful, that will last, and help prepare them for a career in the sciences. So always I sometimes I feel like there's this big chasm between what I do every day, which is work with my elementary education students, and my background in meteorology. And so what I've done is help increase understanding and help tease apart our distinctions that we make, and sometimes we fail to make sufficient distinctions between weather and climate, and our understanding of climate change and our sensitivity to this changing environment that we face and see outside of the window. Just last week, there was this interesting news piece about West Virginia and our susceptibility to flooding in recent years, and then how we are coal keeps the lights on. You know, we are a very much supporter of coal and coal-fired generation of our electricity, yet that is releasing carbon dioxide in the atmosphere, and it could be making the flooding worse. So we're feeding into the cycle of the flooding events that have occurred in the last 5 or 6 years. They're huge. And so it's a difficult issue. And so one of the people interviewed for this, she was the mayor of Clendenin, really sweet soul, talked about the flooding that they faced in 2016 in Clendenin. And the reporter asked her, well, so what do you think about climate change? And she's like, well, warming. She's like, does it feel warm out here to you? Because it was cold, right? And so here it is, mid-April, and it's cold. So that's the weather, not climate. So it's difficult to tease apart in practice and in our daily lives. And so I'm interested in researching and understanding that better. And so I love this robots, see a need, fill a need. Always, see a card up on the wall, pull that card down, find a way that you can marry your interest, your things that really make you excited with your career, with your research interests. And so that's what I've tried to do over and over throughout my career. And so climate change, is a huge amount of importance to society. And, I almost thought about changing this picture because, this is like the quintessential picture of climate change. Oh, the poor polar bears. It is very poor for the polar bears. But what I tell my students, and what, that news piece was about, is that in West Virginia, we don't have polar bears, right? So, okay, climate change doesn't bother us. We don't have polar bears. What climate change will bother us is flooding. And then where it will bother us is if the price of bread triples, right? Think about, our supply chain issues that we've had since COVID-19, toilet paper, right? 2020 will always be the year of toilet paper, right? So those supply chain issues, if the bread basket suddenly gets less precipitation and irrigation now is 3 times, or maybe it's impossible for them to bring in sufficient water to keep our bread basket generating the bread, we're going to have a problem. And it's not polar bears. It's going to be the price of food in the grocery store, right? Because we're changing where our storms, where our fronts, where our cold fronts, where our warm fronts migrate. And we can see a dramatic lowering of precipitation in West Virginia. The models suggest we're going to see an increase in precipitation. right? So those flooding events are probably not going to be the 500-year flood. We might have to change them to be the 5-year flood, right? They happen every 5 years, not 500 years. So anyway, it's a huge importance to our society. It takes a lot of interdisciplinary connections and teasing apart, right? Our own sensitivity and our own bias of our weather that we experience versus changing those predictions and those forecasting of our future climate. And so there's a lot of opportunity there to raise awareness, not only of the issue, but also better educate our students and hopefully help my students see the distinction between the current cold snap of this week in April versus changing the climate. So what about Pluto? So how does Pluto all fit in this? So I hope you join the talk to learn about Pluto, because I think Pluto is fascinating. In 2006, right? Some of you might have, been in school when this was taking place in 2006, when it was reclassified. And so I learned the mnemonic device. My very educated mother just served us 9 pizzas, right? To learn the planets in order. For Mercury, Venus, Earth, we're the 3rd rock from the sun. Then comes Mars. Those are the 4 inner terrestrial planets, very small rocky planets compared to the big gassy planets, which are Jupiter, just served us 9, is Jupiter, Saturn, Uranus, and Neptune. And the pizzas, the best part was Pluto, right at the very end. So Pluto is not a gas giant in any way, shape, or form. It's smaller than our moon. And so it was reclassified as a dwarf planet. Currently, there are 5 objects accepted as dwarf planets: Ceres, Pluto, Eris, Makemake, and Hawaii. So Ceres I put in yellow there because Ceres was actually discovered pre-Pluto. So Ceres was discovered in 1801. Pluto was discovered, I have it on the next slide, in 1930. Okay, so Ceres was discovered in 1801 and has gone through 3 reclassifications. It was first classified when it was discovered in 1801 as the 8th planet, right? The 8th and 8th planet hadn't been discovered. Neptune was later. Right. And so then they discovered there's a lot of rocks out there in between Mars and Jupiter. So that's now we call that the asteroid belt. So Ceres became a part of the asteroids and was reclassified as an asteroid in 1851. Then in 2006, it meets the classification of a dwarf planet. So we have reclassified other things, but Pluto has gotten a lot of interest and a lot of press. So the official definition of a planet, which was established in 2006 by the IAU, I forget, International Astronomical, somebody help me there. I don't know what it stands for, but it's all the really smart people in physics and astronomy, professional society, I'm sure, International Astronomical Society. And so they decided that these were the 3 defining characteristics, and Pluto has the first 2, but not the 3rd, right? And so it's in orbit around the sun. It has sufficient mass. So basically that it has either pulled everything in or it has expelled everything. So it is so big that its force of gravity is so, it has cleared its space, its orbiting space. That's basically what B means, right? And has cleared the neighborhood around its orbit. Pluto and Charon, which is the primary moon of Charon, they're almost the same size. And so that's why, in fact, they're almost like I was reading about it again today, that they're almost like a bi-planet system. They orbit each other, like the moon orbits us. And although the moon pulls on our oceans, right, to create tides, it doesn't pull on the orbit of the Earth. Pluto and Charon pull on each other's orbit. So that's why it didn't meet the criteria that they set. And so it's beyond mnemonic. Science isn't a collection of facts, but it's a process. I always sort of simplify science as it's a noun, which is the collection of facts. That's the book, right, that you purchase. That's $300 from the bookstore when you're in college, right? And so that's the collection of our understandings as they currently are. But it's also science is the verb, the practice of doing science, of uncovering and finding new ideas and new concepts and new relationships that help us better understand how the world works. And so here's Pluto, right? This was Clyde Tombaugh, and in fact, they opened it up, and I think it was 11-year-old girl that suggested Pluto be the name of this ninth planet that was discovered in 1930. But I want you to look, my next slide here, this is an animated GIF that starts with Clyde Tombaugh's view of Pluto. Look at those, talk about fuzzy picture, right? Very pixelated, right? And I was reading again how he discovered they would take plates, you know, of a time-lapse capture of light, and then they would compare one night with the next night. And always, and back then in 1930, there was no computer to flip back and forth to look at the pictures, or now we have image processors that do that, right? They were reliant upon the naked eye to do this. And so by that light, right, that speck of light that was in a different place from the background of the stars, because that's what planet means. Planet comes from the word wanderer. So against the background of the stars, which pretty much stay in the same place, right, as we orbit around the sun, the planets wander. They move in a different trajectory. And sometimes they even go backwards from night to night, right? Your planet is in retrograde. So as you can see, as our technology to see in the outer reaches of our solar system has improved, and it made a huge jump with Hubble. The Hubble Space Telescope was launched in 1990, which was when I was a freshman in college. And so that was the dawn of, now we can really see much better, because we're not looking through this ocean of the atmosphere. So when we have telescopes and we look through the atmosphere, it's doing a lot of things to the light, that very faint light, as it works its way through the atmosphere, gets all messed up. Again, thinking about looking through a pool, right? It gets all fuzzy, and we're looking through this pool of atmospheric gases. And so once we launched Hubble Space Telescope, which is still in orbit to this day around our Earth, looking at the outer reaches, not only of our solar system, but beyond into galaxies. It's just amazing what the Hubble has discovered. So many of these pictures are from the Hubble. The latest ones are from a NASA mission that was launched, right, to explore. And I'll talk about that in a second. It was called the Horizons mission. So just to familiarize yourself, Pluto is in the Kuiper Belt. And so you can see the orbits, these circles, these large circles in the center are the orbits of our large gas giants. Our Earth's orbit is so close to the sun here, it doesn't even make the resolution of our picture, right? We are so close to the sun compared to the orbits of those really large gas giants. And so you can see these are the orbits of Jupiter, Saturn, Neptune, and Uranus. And outside of that is all these objects that are called the Kuiper Belt. And you can see that at the bottom, all the orbits of the other planets lie in a flat plane. We call that ecliptic plane. And so all the 9 planets orbit. I always tell my students, like a plate, right? The sun is in the center of the plate, and all the orbits of the planets are orbiting in a mostly circular orbit around the sun on a flat plane. Pluto, like many Kuiper Belt objects, its orbit is tilted. And it's very much, see how it's very much not centered on the sun. And has a very strange orbit, very elliptical orbit around the sun. And so there's many other Kuiper Belt objects that are out there. Here is a few others in size comparison with the Earth. And the moon's diameter is 1/4 the size of the Earth. And you can see that Pluto is, maybe it's like a fifth of the diameter of the size of Earth. And so it's much smaller. And so Sedna is another object that is in the Kuiper Belt. And definitely prior to reclassification, it would have been a planet. Right? It would have been a planet. It was big enough to be a planet. And so when you compare Pluto with these other objects that have been found in the Kuiper Belt with better technology, and again, the reason why we saw Pluto in 1930, because it was the reflected light of both Charon and Pluto together, not just Pluto. So these other Kuiper Belt objects didn't have a large moon. So we didn't see that light with those really fuzzy pictures that we had in 1930. And so it came a question of, how many planets do we want to memorize? And so here's just a comparison of the moon, which is about the size of the, the Pluto and Charon, which Charon is the moon. And again, they're kind of like a bi-planet system. They kind of orbit with each other. And you can see how they compare to the size of the United States in the background. And so, but not everyone was happy with the reclassification of Pluto. It was a fun name. There's, you know, it was like a Disney character. What are we doing? But the solar system hasn't changed. It's our understanding. It's our technology. And so these are pictures from the Hubble Space Telescope in 2006, when this was brought forth to the IAU to be considered for reclassification. Because when you see these, and this is our best pictures at the time, right? This is way better than that fuzzy picture that Clyde Tombaugh had in 1930. And it's really the combination of the light reflected that we could see of both Pluto and Charon. And so we still launched, Pluto's still important. In fact, this Horizons mission was launched when this was taking place in 2006. And it took, I always tell my students, 9 years. It took 9 years for our satellite from Earth to reach Pluto. And we were committed to Pluto, even as a dwarf planet, because we learned a lot about Jupiter on the way there. We're still learning from the Horizons mission. And so it took 9 years to reach Pluto. And this is just a kind of like a timeline of when it was launched. It did get a flyby pass by Jupiter to get a little swing shot to make it out to the far reaches of our solar system and the Kuiper belt. And so it's still continuing to send back information. Here is again another view, again looking down. Here's the tight little orbit of Earth in comparison of the orbit of Jupiter, Saturn, Uranus, and Neptune. And again, that really wacky orbit of Pluto. But there were several discoveries made with the Horizons mission, and they definitely have discovered far more ice and water, even on the surface of Pluto. Captured very, very cold. No life we think exists there. Negative 300 degrees on average, I always think I was reading. But these are some of the pictures that the Horizon mission sent back. And then we have to think about the mnemonic, right? We have to transform our sort of understanding to that we have 8 planets. I teach this mnemonic device. Now my mom serves me nachos. My very educated mother just served us nachos instead of, you know, all the other ones, that pizzas and sednas and all, you know, how many Kuiper belt objects do we want to have classified as planets? And so we just changed our classification system to best represent our current understanding, which could change again. You know, science, the books, maybe that's why they're so expensive. They have to keep publishing new ones because our science understanding keeps continuing to grow and to change. And so the term planet has been changed multiple times. And in summary, Pluto's just a lot smaller than we thought. We were capturing light from Pluto and its very large moon, Charon, and that's what allowed it to be discovered in 1930. It's large, but it's not the largest Kuiper belt object, but it's still important. And so here is the atmosphere. These are pictures from the New Horizons mission. This is the New Horizons mission looking back through the atmosphere of Pluto. It definitely, it's a very thin atmosphere and definitely has a blue tinge. And so that showed up nicely on that. This is, again, a close-up picture of some of the topography. And the ice on the surface of Pluto is red. So that's also very interesting. And it's definitely has multiple mountains and craters like our moon because of that very thin atmosphere. Lots of asteroids strike the surface and aren't, like, we are very fortunate to have a very nice atmosphere, which gets rid of most of our incoming asteroids. And so this is the geology map that was done with the data from the Horizons mission as well. And so how science works is that it's tentative, it's subject to change. And our understanding about Pluto has been transformed in the last 100 years, right? I mean, it was almost 100 years since Pluto was discovered. And so with 1930 discovery of Clyde Tombaugh. So we're continuing to change our understanding of Pluto. And so that understanding led to, we probably need to change our nomenclature and how we classify things. In life science, this happens at probably as often as astronomy as well, because we discover life and living things in the strangest places that we weren't able to go to 100 years ago. You know, we're able to now to go down to we talk a lot about the Mid-Atlantic Ocean ridge in the center of the Atlantic Ocean, where our plates are diverging, bringing up volcanic activity from the under the plates, the lithosphere. And so that there's life down there in the pitch black darkness of the Atlantic Ocean, and crazy life that's in deep waters of the Marianas Trench in the Pacific Ocean. It tries and finds a way to exist in the strangest places. So we have to redefine our textbooks and how we describe living things in new ways, because not all plants need the sun for photosynthesis. They generate their food in other chemical means because they have access to chemical energy. And that was not something that was known in the books that I read when I was a kid. You know, so our understanding changes almost daily. And so how does it relate to me and to you? Be open, be willing to change, be ready to change, be excited to change. I know that I've tried to do that over the years as my own interests change. You're like, all right, let's do something new. This is exciting. It's a fun time to be. And so science is dynamic, new data, new technology, new ways to collect information from space. The Hubble Space Telescope has been transformative. I'm just fascinated by space and our understanding of the universe. It's just beyond comprehension, actually. And so humans do this. And so you could be a part of this exciting opportunity of the future. And that's what I want to work with teachers to harness the interest that our students have when they come to school about how things work, and keep fostering and keep supporting that by doing science through hands-on ways, right? By passing out materials. Let's just not read about how to light a light bulb, but let's pass out bulbs and batteries and wires, and how do we make this work? We had a great day in science last week, right? When we built dams. How can we stop water flowing? How can we stop this process of erosion? And so we had my students have a budget, they're mayors, and they're going to create a dam. And so it was a super great day, super fun day. And those are the kinds of experiences that are meaningful for our students, that stay with them, that they carry through and they pursue. And the ultimate compliment as an educator that you can have is when they come to you after class, or the parents come to you after class and like, boy, Johnny is so excited about this. I bought him this book because of what you started, the interest that you created in your classroom. And so this is one of my favorite quotes: a rocket won't fly unless someone lights the fuse. And so this comes from the October Sky, the book movie series, which is from the book by Homer Hickam, from Rocket Boys. And I love this because he's a West Virginia boy. He is a son of a coal miner, and he was raised in a really important historic time with the launch of Sputnik and the space race. And there was a huge push in the school system at the time, because there was a fear that the United States was holding back and we were going to be left behind in science and technology. And so he was able to really capture and capitalize on that time. And I don't want another Sputnik to happen. I want us to sort of infuse innovative inquiry-based science right now, and have very high expectations of our students, because they can do it with preparation, with the support of you as a parent, and you, most importantly, as an educator. So If you have any more questions, you'd like to reach out to me. I think I did pretty good on my 45 minutes. My students, I kind of go over a lot, but I appreciate you joining me for the talk. And I think now make sure for students, my students on the call, if you would make sure you have your name and a question in the chat box. We'll have Eli pick out a few of those.
Yep. And there are already a lot, so I'm definitely not going to be able to get all of them. So I think we'll just start from the top. We'll pick one out here. Let us see. So the first question was from Faith Hawley. It says, what part of your career has been your favorite, and would you have done anything differently?
Oh, I say right now, I have the best job in the world except grading papers, especially lesson plans. My career, geez, I love what I do now. I think without a doubt, I never felt like a true like card carrying weather geek. And so that was, I wouldn't say that it was forced. I really did enjoy the work that I was doing at Lincoln Labs, and then of course teaching meteorology. But I feel the future is our elementary educators. I mean, you hold that curiosity, and it's so important and yet so fragile that it both excites me and frightens me, because science has really been pushed to the back burner in our elementary schools because of the focus on No Child Left Behind with reading and math scores. And I know, I mean, reading and math are so important, and you know, it's their future. But if we can get them reading about things that you've sparked interest in, right, and provide context. I'll never forget my daughter. I had the opportunity to take my family on multiple locations, and I took 17-year-olds with a grant from the National Science Foundation to Costa Rica. And I brought my family at the end of the kids trip, the high school trip. I brought my family, and we stayed a few more days. And I'll never forget my second grade daughter coming home from that next year saying, Mom, I know all the answers in science. And I'm like, really? What's it about? And she's like, we're learning about the rainforest, because we had just been to the rainforest, right? We had just walked through that lush vegetation and looked up and saw the sloths on the trees and the monkeys. And I mean, you have to provide the way to make science real and make science hands-on, so that it isn't about memorizing facts. It's really about their interest, and it resonates in a way that will stay with them and have an opportunity to increase that interest, that maybe this is a career that I'm interested in even as a middle schooler. So.
Okay. Another question from my wonderful wife, Julia. She said, do you miss being the climatologist for West Virginia? And if you do, what do you miss about it?
So I did. I was able to serve as the state climatologist for a brief period when I was still working at state. And it was an interesting opportunity. I loved the collaboration that I was able to do with the National Weather Service. But Kevin Law now is a faculty member in the geography department. He was hired the same year as I was in 2007, and he's been able to start a meteorology program within the geography department. And so he's taken on that role as the state climatologist. And I think he's doing a great job. And it's really an opportunity to collaborate, especially with the time of climate change, with other climatologists around the country.
Okay. This one is from Morgan Miller. She asks, what was the most challenging part of your career?
Oh, well, I think the challenging part of my career when I first began, and I was living at Lincoln Labs outside of Boston, and it was so they were doing such interesting things. That's the one where they were working for making that predictor product for air traffic controllers. And it was challenging because I was away from my family. My husband took a job where he was traveling, and I was, I had a newborn. I had like a 1-year-old, and I had a 45-minute commute one way without traffic. I'll never forget leaving one day from work, and it took me 2.5 hours to get home, and because it started snowing, and so thankfully my baby in the back seat just slept the whole way. But I walked in that day and I told my husband, and I said, no career is worth what I just did. I have to find a way to create a life balance that allows me. I knew I wanted to do something professionally, but I didn't know what it would look like, and how what it would look like if I found a way to move back home to West Virginia, because to work as a meteorologist in West Virginia, I'm going to be on TV, or I'm going to work at the National Weather Service, and neither one of those really spoke to me, in that I was like really interested in doing that. And so I wasn't sure, and so that's when the opportunity came for me to work at State, and teach meteorology for several years. So that was the toughest time, and it was more of a personal issue, so it was tricky.
Okay, I'm just scanning through the questions here because you answered some of them after they had asked them in the slides. Let's see. Okay, this is a good one from Sophie Herbert. Says, what is your favorite part of teaching future educators, and what is the most challenging part?
Oh, my favorite part. I really love teaching about the moon in CI 248. I think that's super fun, because we track the moon for several weeks on their own time. And I use an app that I called Skyview, which is an augmented reality. So that helps you find the moon pretty much anytime, right? The moon could be below the horizon, or I always encourage them to use their own eyes as well. And so I really enjoy that, and helping them transition it's about the moon changes its shape that we see from Earth because of the space between the sun, the distance between the sun and the moon. And so to have them collect that data with their outstretched hands, measuring that and seeing how that changes a little bit day by day, to then going into a physical model where we go into the dark room with the single light in the room, and everybody is holding a moon, right? A fake moon, a white foam ball, if you will. And that single point of light now serves as the sun. And now we can see how the light that we see, that illuminated part, is the shape of our round moon up in the space. So I love teaching about that. The challenging part is the lesson plans, right? I mean, the challenging part is to keep pushing students in the direction of not just reading about science, not just watching a video about science. The challenging part is always pushing them and pushing them, shoving them in the direction of how can you create an experience for your students, right? So that they can have that hands-on experience and opportunity to really deeply learn those science topics. That's the greatest dream, but that becomes sometimes the greatest challenge. And most of my students get there. They get there by the end of the semester, by hell or high water. We get there, but it's challenging, and so grading those lesson plans is time consuming. And that's what I tell my students is like, I want you to spend a lot of time writing it. And trust me, I'm spending that much time, maybe times 2, grading everyone's, right? Because I got 24 to grade. So that is challenging, but great opportunity. And most of us get there. We get there by the end of the semester.
All right. We'll just take maybe 1 or 2 more questions here, but I found this one probably one of the most important questions that I've seen in this chat. What kind of challenges did you face as a first-generation college student, and how did you cope with those challenges?
That's a great question. And the interesting thing when I think about my own kids as they went to college, they didn't have this, right? Because I was a cheerleader, and in fact, most of them ended up at Marshall. So I was just down the hall, or I mean, I was the building next to. They could go and ask a question or whatever. I think my lifeline truly was the honors college, and making the friends that I had through the honors program, which was it was a program now, but it's the honors college. But I'll never forget the secretary that was there in the honors office. I could go to her, and when I walked in the door, she knew my name. And so that meant everything, because we all start off in the big lecture halls, right? And we all start off kind of like a number, and so so having a person and a place to go to ask my questions was huge. And to have someone to go who knew me and smiled when they saw me as I walked in, and so that she was a godsend. And I think that the combination of that, the friends and the network, and I, I enjoyed being in the band, but it was definitely not my culture. And it wasn't something that I wanted to continue to do. I was like, I remember thinking I came to college to learn stuff, not just like party with the band. And so, I mean, that was a great place, because I made friends pretty right off the bat by being in the band, but those were probably not they're not the friendships that have stayed. Those were the ones that I found through academics and through the honors college that shared similar life goals and passions as I did. And so, but it's important to find that network. It's important to make connections with people who can, and it's important to ask questions, it's important, and then to find the person who can help you find the answers.
Very, very good advice. I'm barely not a first generation student, because my dad graduated from college maybe 5 years before I went to college. So, okay, so this will be our last question for the Q&A. There are many more. If you want to, you can go back through and read them at your own leisure. But this one, I think, kind of hits home as to what we're trying to do with the Faces of Physics series. It says, how do you recommend that we encourage our future female students to not be intimidated by male-dominated fields and want them to learn about science?
So one of my areas of interest and research as well, in terms of working with pre-service teachers, is the role of mindset, and fixed versus growth mindset. And so if you have a growth mindset, and which I've tried to do in my life, is instead of being intimidated or afraid of making mistakes, see mistakes as an opportunity to learn more. No one likes to make mistakes and look silly in front of everyone else. And so, I can't say that I've been excited when that has happened. But when I see an opportunity to grow in something that I maybe need more growth in, I pursue that. And so that's a growth mindset. You recognize that your skills that you have today do not have to stay the same. You could become a better math student if you put the effort in, right? And so a fixed mindset is that you're fixed, or your skill sets, your abilities were kind of defined and determined at birth. You were just born not a good math person. You were just born not a good writer. And so sometimes it becomes an excuse not to try hard, right? Because this is just your predisposition and your predisposure, and so unfortunately, many of our female students expect perfection, and so I was the leader of the pack. I expected perfection and 4.0, right? I mean, if I hadn't been able to get A's, I probably would have turned away, right, along the way. And so what happens is that our female students, and again, it's a broad stereotype, and Carol Dweck is the researcher from Stanford who has put forth the research about mindset. And she has written up, and I thought this was very eye-opening, is that when we consider the relatively comparison of the maturity level of incoming kindergartners, like preschoolers, right? And so we see on average that our females tend to mature a little faster, difference in the brain and all this, in the physicality of men and females. And then the boy students. And so those early educators really expect and push for the perfect paper from the females, right? From the little girls that can sit in the desk. Perfect paper, right? Dot your I's, fill in all the color in the lines, versus the little male student, Johnny. It's like, just finish the paper, Johnny. Just sit in the chair long enough to finish the paper, right? Because physically their maturity is in a different level than stereotypically than the female students. So over time, right, sort of graduate that through school. Females expect perfect papers, and the male students, let's just get by. C's get degrees, right? Versus a C to a female student means I need to run for the hills. I'm changing my major. I can't do this. It's not for me. So what do we do, right? I mean, so one, we need to be careful promoting perfection from the beginning. And two, we need to help our female students realize that perfect grades are not the end all be all. Well, should we just move away from grades? I mean, many schools are moving away from grades. It's about mastery. It might take you multiple times or more effort to master. But ultimately, that is the most important, versus we shouldn't define ourselves and our abilities by grades. But unfortunately, a lot of our female students do.
Well, I think that about wraps it up for this talk. So for those of you watching at home, again, I would encourage you to subscribe if you want to hear more talks like this. Hopefully I'll be able to get some great talkers like Dr. Cartwright here throughout. I think we're going to do one in May, or we're going to try to, and then throughout next semester, we will have a few other talkers. So yeah, thank you, Dr. Cartwright, and thank you everybody watching.
Yes, thank you again, Dr. Cartwright. Wonderful talk.
Thank you. Good evening.